Hello, friends. Hopefully, you watched the last video about moon phases. You watched the crash course video about it. It's all starting to make some more sense. So now we're going to look at how to put those on a star chart and a geocentric diagram. Here we go. So we talk about the star chart diagram. We're looking at that flat layout of the ecliptic, that path of the sun, the plane of the solar system, and the celestial equator, how they compare to one another. So when drawing these, it's easiest, I think, to start by simply drawing a flat line. Then make like a sine curve to represent that star chart. And if you can, draw it a little better than this. Make it a little more even, maybe. That's a little better. So this represents that night sky as we're looking at from it. So that puts the west on this side of the diagram and the east over here. Remember that over the course of several months, the sun progresses from the west to the east in front of these suns. That leaves this lowest point in the northern hemisphere sky as December 21st, or winter solstice. And if the sun's at the lowest point in the sky, that means it's crossing the tropic of Capricorn. That makes this point, or the highest point on the ecliptic, summer solstice. Or June 21st, on average. I mean, it varies a little bit. Sometimes it's the 19th, sometimes it's the 22nd. Once in a great while, the 23rd, not often, but it does happen. And that's a whole different complicated story. So we're going to stick with this right now. If it crosses here, then it's crossing the Tropic of Cancer. That makes this point right in the middle, March 21st on average, or spring equinox. Solstices are when the sun's at its extreme. Equinoxes are when the sun is crossing both the ecliptic and the celestial equator. This is our celestial equator, the ecliptic. Spring equinox is here, and that makes this point the same as this point, and that would be fall equinox, or 6 months later from March or September 21st. It's coming up. If it's December 21st, the sun will be right here throughout the whole day. Now, if I tell you it's the full moon, then we know from our last video and the diagrams we've been looking at that it has to be 180 degrees from the sun, or at the summer solstice position. So the moon will be located here. If it was new moon, can you do it? You can do it like that. If it was new moon, the moon would be located here with the sun. Can you see this okay? Should I pull you in a little more? Come closer, friend. Excuse me. So this would be new moon. If it was first quarter, it'd be 90 degrees east, just like the moon moves in its orbit. So where would that be? Yes, very good. Here, at the spring equinox position. And again, if it was full, it'd be here, or 180 degrees away. So let's add a little more information. It says first full. Then, if it was third quarter and it had progressed 270 degrees east of the sun's position, or 270 degrees around in its orbit, just like we talked about, it would be at the fall equinox position, or third quarter. You might want to pause the video and write that down. I'll wait. Good. All right, now let's think about how we can take this information then and transfer it into a geocentric diagram. So I told you to pause it. All right. So if we were thinking about a geocentric diagram, we could again set it for December 21st, winter solstice. Let's say at sunset for a full moon. You with me? Here we go. First, put your arch in. Then your straight line. Draw your geocentric diagram. Label, of course, north, south, west, and east. Put your north celestial equator in. I'm sorry, north celestial pole. My bad. Point the NCP. Remember, in the northern hemisphere, it points to Polaris. And then 90 degrees from that, drop in the celestial equator. And then about 23.5 degrees from that, the Tropic of Cancer. And 23.5 degrees south of the celestial equator, Tropic of Capricorn. Very good, friends. Very good. So now we look at the time. We look at the date and the time. It's it's winter solstice. So we know that the sun is located somewhere along the Tropic of Capricorn. Oh, the sun's on the floor. I got it. So it's sunset, which means it's where? That's right, in the west. It's setting. So it's going to be down here. Now the moon is 180 degrees away from that along the ecliptic. So if we put in the ecliptic, and I hope this isn't too confusing, it's going to run like this. Oops. Follow the solid line, children. Follow the solid line. Ignore this. Pretend like that never happened, just for everyone's, all right, for my mental health. So it's 180 degrees away, or it's sitting over here, getting ready to rise, because it's the full moon. So it's over here in the east, on the eastern horizon, 180 degrees opposite the sun. If it was the equinox, it would be here. I want you to try this problem set now. Keep these ideas in mind. Email me with any questions. And I hope this helps you understand how these diagrams start to connect and show us the same information from different perspectives so we can better locate objects in the sky when doing observational astronomy and learning about how the world around us really looks. So I hope you enjoyed the videos. And if you didn't, well, at least I hope they're useful. And I hope they help with the homework. And I hope to see you all soon. Take care of yourselves, my friends.